Hello, it's Ryan here from RLF Vacuum Cleaners in Lakenheath. In today's video, we're going to be talking about relays and contactors. The other day, I was working with a guy and he was asking what the difference was between a relay and a contactor. So to start off with, we'll start off with contactors because they're nice and simple. A contactor basically is just a switch, simple on-off switch. I've got a selection of contactors here. This is a big 65 amp one. 45 amp, 20 amp, and this little one at the end is 25 amp. But very simply, all they basically are is just a switch. So what I'm going to do is I'm going to energize this one here because this one runs on 24 volt, and what happens is magnetic coil, push that in, connect the contacts together, and what it basically do is it connects the top to the bottom. So I'll bring in power supply like so, connect that up. And that contact's pulled in. That's basically connected it. Now you can get some contactors that work the other way around. They're connected all the time, and then when you energize them they disengage. But majority are like this. And simply as soon as you remove the power, contact springs up, and these are no longer connected. No beeping. And they do this by having basically just a magnetic coil. Bring my multimeter in. The resistance is 42 ohms at 24 volt. So basically got a big magnetic coil, pulls these contacts in. That's basically a contactor, it's basically a switch on or off. You can get fancier contactors like this one here, where on the front you have like an auxiliary module, so when the contactor is pulled in, got this little bit on the back that pulls that in, that basically closes in two contacts. So in a control system, you know that your contactor is pulled in by this little switch. Simply sits on the front like so. Contactors are very simple. This is the best one. Contactors have A1 and A2 terminals, that's your power in, and then you have your main big chunky terminals straight through. Contactors, they're very different sizes. This is biggie, this is the big one. You can get bigger ones. They all vary in size. They all do various different things. Now relays is where we start getting to the more complicated bits. So I'll bring some of them in. And I've got some relays in front of me. Relays are basically like a contactor, it's smaller, but they can do lots of different things. We'll start off with a basic relay. This is just a single relay designed for Raspberry Pis and other microcontrollers. I like this one because it's got a really good diagram on the back. Basically, you have your coil voltage in here, so you have your 5 volts. Good thing about relays is you can use different voltages to switch different things. So you have your coil voltage here, and then you have basically you've got your switch here. So this will be normally closed, normally open, and when you energize it, it switches over. So you've got common, come in the middle, and it either goes to that one, that's that contact there, or that contact there, on the front. We've got this diagram on here, which is basically the same. I'll focus. That's better. Yeah, so you basically have your common in the middle, normally open and normally closed contacts. This one's a bit different to the other one, a bit bigger, but that's basically, it's just a mechanical switch that either goes to normally open or normally closed. And then for other relays you can get these relays like this, 24 volt. You can actually pull this particular one off, and you can see got your coil down here, and then you've got your common and normally open and normally closed contacts. I quite like these relays, they're nice and simple to work with. I've got a base here, and this one's nice and labelled, so you've got all your commons at the top, you normally open, normally closed, and then on the bottom you've got your A1 and your A2 terminals, and then you just plug your relay in. Of course they can come in like this. These ones are quite good, they got a little lever on them, lock them in, they pull out. This one's basically the same. Got your coil, 2 big pins, and then you've got your common and normally open and normally closed. These ones are just to plug in. Push them in, they lock. This one's basically the same again. This is what I call a solid state relay. This doesn't have any mechanical contacts, it's purely electric. So if I put a voltage on these two, basically it'll conduct, and then we disengage the voltage, it'll stop conducting. These are reasonably good. They do get quite warm, but these are good because they're nice and thin. They can take quite a high current, and there's no mechanicals in them. So it's a solid state relay. It's not quite a mechanical relay. These are purely electronic. I don't tend to see many of these. These are quite rare out in the wild, but they are about. Basically, put some voltage on there, material inside will start allowing current to pass through. These are what I'm going to call specialist relays. This particular one here is a potential relay used on big motors that are used on single phase. These are quite common in big pumps, big floor scrubbers. Basically what it is, the way these work is, with these single phase motor, generally you'll have a winding and then you'll have a capacitor for another winding to slightly offset the phase, while on bigger motors you have another winding with even bigger capacitor to get it started. That's what they call a start capacitor. And what this relay basically does is in circuit, and when the potential voltage, when the voltage has reached a certain point, it will disengage the contactor, disengage the capacitor from the circuit to stop it blowing up. These are very specialist. You see them a lot in air conditioning, floor scrubbers, big motors that use single phase. Basically what happens is you have your 2 capacitors to give you 2 extra phases to get the motor started, and then when you're running you switch that capacitor off and then you run on your slightly opposite phase with your run capacitor. These are pretty handy. Back in the olden days they used to have a mechanical switch, but now they use one of these relays. Again, probably never likely to come across one of these, but it's good to know they're out there. Here's when we start getting to some specialised stuff. What this is a voltage relay. Don't know how that's going to show up on the camera. Ooh. Basically what this is, you can set your maximum voltage, time delay and your minimum voltage, and what you do is you put your power in the top, A1, power in the top, and what it does, it'll monitor the voltage. So if the voltage goes too high, it'll switch the contact over, and if it goes too low, it'll switch the contact, and then you can have a time delay in case you've got a slight blip or whatever. But these are very good, again, for big motors and other things where you need a good voltage, because if the voltage starts dropping you'll draw too much current and it could cause damage. These are pretty good. Got a couple of lights on there. You've got a light to say it's energized, and you've got your light to say that your contact's energized. These again used mainly in more industrial applications, but you do see them now and then. Then we have one of these. These are a current sensing relay. Basically, if we get out to the camera, let's focus in. Again, like the voltage one, you can have your maximum current, minimum current, and then you got your time. So if you, let's say you wanted the big motor was failing, and suddenly it started drawing a lot of current, you can use this relay to warn you. You can wire this up to an alarm or an auxiliary or whatever to warn you that your motor's drawing a lot of current. And if possible, you could actually turn the motor off or sound an alarm. Various different ways, depending on how you wire it, but these are good. Start to see a lot more of these. If you go into EV charging or maximum demand sort of thing, you can wire one of these up in a priority arrangement. So if you've got an electric shower and you have a high drawing electrical appliances in your house, you can have it so it can turn your EV charger off if you turn your cooker on or turn your shower on. Very clever bits of kit. Start to see a lot more of these out in the wild. Again, these are brilliant because obviously you don't want to draw 40 amps from your electric shower and 30 amps from your electric car charger, if you've only got 60 amp main fuse, obviously you run the risk of blowing the fuse. Little relay like this, depends on, it's all about how you wire them up, but you can do that so you can turn one off, give priority to one, priority to the other. Brilliant bits of kit. Now, this one here, these can be a bugger sometimes. This is a timer relay. What this basically is, you put your power in, and then you can set this little dial to basically delay, or so basically you can set that little dial up, you can set the time and use that little adjuster knob. So this one is currently set to 1 to 10 minutes, and you use the little knob 1 to 10. This can go from anything from 0.1 to 100 hours. Now you get a bit more fancy, and this is actually quite a basic one. And I'll have a play with it. Again, these are very handy. Certain applications, if you want to run something a bit longer, stop something, various different ways, depending on how you want to wire a circuit. But these are brilliant. Bit pricey, but you've got your common at the top, and then you've got your two outputs at the bottom, which can be time delayed. This is relays. There's a lot more relays I'm not showing you here. This is just sort of the basics and a few complicated ones. But basically, relays are the backbone of appliances, controls, all sorts. Relays can also come in handy. What I like to do is I like to play around with microcontrollers and things like that. Now, if I wanted to fire up this 45 amp contactor, this microcontroller only puts out very limited current. Now, I had this fired up. This draws quite a considerable amount of current, so you wouldn't be able to drive this contactor from this microcontroller simply because it draws too much current. Also, the fact that this runs on 3.3 volts, has 5 volts in, voltage regulator 3.3 volts, just physically doesn't have the current to power it. What you can do is you can get this microcontroller with limited current to power this relay. This relay can then be connected directly to this contactor. So basically the microcontroller energizes the relay then has enough current switching capacity to engage the contactor, or depending on what this microcontroller is going to, you could wire this relay up so it goes via the voltage relay. So wire this through. So is the voltage good enough to power the load? If so, you can wire up to the contact. Then you can wire up to the current relay. Is when the contactor is going to be energized, is it drawing too much current? Yes or no. Wire this up, and then you can wire up to the timer relay. So basically what you can do is you can send a signal to the relay. This will be good, voltage is good, so that'll switch. Current will be good, and then we can send it to our timer relay. We want to delay the start of it, I don't know, by 10 seconds. Once all these parameters are met, contactor will then engage and power whatever you want. But of course there's millions of different combinations. You don't have to have voltage, you don't have to current, you don't have to have timer. You could have anything you want. You can also get phase relays. Obviously I'm in with my shed, so then you've got single phase, but you can get phase rotation, make sure the rotation's alright. You can get phase loss relays in case you lose a phase. There is absolutely hundreds of different variations of relays, and if you're interested in them, I recommend you looking them up on the internet. Various different places that sell relays, various different manufacturers that make them. You can get level relays, all sorts, on and on and on and on and on. So I highly recommend, if you're interested in relays. Basically most of the relays you'll come across will be just simple mechanical devices like this, open or shut, open or shut, open or shut. But you can get lots of different fancy ones that do lots of different things. I do a little bit of contactor and relay work, part of my work. So what I'm going to do, what I done was, I bought a big box full of old second-hand relays, circuit breakers, contactors, the lot. And basically played with them. And once you start playing with them for a little while, you get a hang of how they work, what they do. And then you can start designing circuits with them. So you can design all sorts of fancy circuitry. And of course one day somebody might ask you, oh, I want to design something for, or I want something to do such and such and such, but I want this, this and this. And you go, yes, I'm going to do this and this. Brilliant. So yeah, this video has been a help. Thank you very much for watching, and goodbye.